สวัสดีครับ In this lecture we will learn about the magnetic field. The magnetic field is a field that interacts with a magnet. Okay, and we may say that the simplest example is the compass. The compass is always point to the north-south direction. It means that the north pole of the compass will point to the geological north, and the south pole of the compass will point to the geological south. Okay. We know that this indicates that Earth is a giant magnet. Okay, and the magnetic field of the Earth force the compass with also the magnet to align in the north-south direction. Okay, it means that the magnetic field will interact with the magnet, but we also know that the magnetic field will exert force to a moving charge. Okay. This means that if we let a charge move through the region with the magnetic field, the charge will feel the magnetic force. Okay, and also it means that if we place a current carrying wire in a magnetic field, there will be a magnetic force on the wire because the current is a moving charge. It means that if the charge moves in the wire, it produces the current. So it means that if we have a current carrying wire and we place it in the magnetic field, the charge inside the wire will feel the magnetic force, and mean the overall wire will feel the magnetic force. Okay. From this result, it's reasonable to expect that the moving charge will generate the magnetic field. Okay. This is similar, or we can say that this is analogy to the electric field. Okay, that the electric field will exert force on a charge. Okay, if you place a charge in the region with the electric field, this charge will feel the electric force. And we also know that the electric field itself generates the the charge itself generates the electric field. So the electric field exerts a force on the charge, and the charge generates electric field. With the same reason, we know that the magnetic field exerts a force on the moving charge. So we can expect that the moving charge will generate the magnetic field. Okay. But if we want to move the charge, it means that we have to apply the electric field. I mean, if we place the charge in the region with the electric field, the charge will move, right? And the moving charge generates a magnetic field. So we can say that the electric field can generate magnetic field. In this case, we need the charge. It means that electric field move the charge, and the charge generate magnetic field. And we will learn later also that without the charge, but the change of the electric field can produce the magnetic field. Okay, and also if the change of the electric field can produce the magnetic field, we can expect that the change of the magnetic field will produce the electric field, and this confirmed by experiments. So today we know that these two fields are the same entity, which we now call the electromagnetic field. The electric field and the magnetic field are the same thing. We can say that it's a different face of a coin or different face of your hand. Okay, it's the same entity. And once we know this, that electric field can produce magnetic field, and the magnetic field can produce electric field. Later, after we study this chapter on the magnetic field, we will study that these two fields can interfere each other and propagate into the space in the form of electromagnetic wave, which is very important property of the electromagnetic field that we will learn after we finish this chapter.